Okay, this is question 6, and we've got two functions. F of x is kx plus 2 and gx is x minus 3k. X is a member of the set of the real numbers in each case. And we've got to find expressions for f to the minus 1 of x, the composite function f of g of x, and then we've got to solve this composite function being equal to 4 for f of g being equal to 7, or for x being equal to 7. Okay, so let's get stuck into the first part. So we've got in part A, section 1, we've got f of x equals kx plus 2, and we're trying to find the inverse function. So we're going to put the f of x equal to y to make our algebra easy. So y equals kx plus 2, and we're going to make x a subject to the formula. So take 2 off both sides. So y minus 2 equals kx. Divide through by the k means that y minus 2 divided by k is equal to x. Now we do the variable interchange to swap the domain with the range and the range with the domain, which now means that x minus 2 divided by k is equal to y. So this is now our output, which is f to the minus 1 of x, and this is what we do now to any value of x coming along. We subtract 2 and divide by k to get the inverse function. Okay, then the second part of the question was to find f of g of x. And in the second part of the function, we've now got g of x, which we're told is equal to x minus 3k, and we are after f of g of x. So we're going to look at the f function. Everywhere we see an f, rather everywhere we see an x in this function, we replace it by g of x. So we start off with the function for f of x, which is k. Everywhere we see an x, we replace it with g of x, which is x minus 3k, and then finally plus the 2, which is this part over here. Okay, expand the brackets out and simplify, so we get kx, or xk, minus 3k squared plus 2. Okay, now we're told that this is the next part of the question. Let's come down to the next part of the question down here, part B. So we're given f of g of 7 is equal to 4. So f of g of x is this equation. F of g is 7 means we substitute 7 in here for the x, and we know that this is now going to be equal to 4. So we get 7k minus 3k squared plus 2 is equal to 4. So we've now got a quadratic, and equate the quadratic to 0. So take everything through onto the right hand side. So we get 3k squared, and we get 4 minus 2, which is going to be 2, and we're going to take the 7 across, gets to be minus 7k. Okay, so the 3k squared is going to cross, the 7 and k is going to cross and become negative. We've got 4 minus 2 to get me 2. And we should be able to factorize this now, so we get 3k. Always work from the prime numbers in case. In fact, here we've got two sets of prime numbers, 3 and 2 are both prime. So 3k times k is 0. We've got a minus and a plus, so we need two minuses in here. And with a 2 there and a 1 there, we'll have the correct factorization. We've got 3k squared minus 6k minus 1k is a minus 7k. Minus and a minus is a plus. 1 times 2 is 2. So we've now got 3k minus 1 equals 0, and k minus 2 is equal to 0, which means that k is equal to 1 over 3, and k is equal to 2.